Hi, this is Nick with Atlantic Laser Scanning Services. Today we're going to talk about some basic principles to use when you're scanning with a FARO Focus scanner, whether it's inside, outside, whether you're scanning equipment, buildings, interiors of buildings. It's all going to be based on the same principles. So to start with, we've got a project where there are no targets being used. This is very common with FARO. They've got an excellent software system called Scene where it will automatically register or put the scans together for you. The critical thing when you use no targets is you have to be able to see at each scan position clearly what you scanned previously. So you're looking for geometry. Now, as we can look at this side of the building here, we see the windows, the doors, the edges of the building. These are things that in the next scan position, we're going to need to clearly be able to see in order for the software to put the two scans together. What the FARO software does is it takes this scan and then the next scan position, and it'll look at the two scan point clouds from above. It'll rotate these two scan clouds until it finds edges and lines, things like the air conditioner coming out of the building, the door, the edges of the windows, the edge of the rooftop. It'll look for these edges and geometry, and it'll turn those scans until those edges match up, those corners match up, and it'll lock the two scans together kind of like a puzzle piece before it moves to the second portion of registration, which is an XYZ, common XYZ points in space. So the principle here is we need to clearly see what we scanned previously before we start our next scan. So we can see as we move the scanner around the corner, it's now disappeared. Obviously, we can't see where it's scanning over there, and that position cannot see this side of the building. So to properly position the scanner, it would have to be on the corner. The corner scan sees both what we scanned previously and where we're going to scan. This corner scan is absolutely critical. If you employ this basic principle, you're going to avoid a lot of headaches later when you're working with the software and trying to put the scans together. Now we've got a different situation where we're scanning outdoors. As you can see, there isn't a building around, there's no equipment that's stationary sitting close by, so we really don't have any geometry for the registration software to use to put the scans together as we scan along the side of this road. So what we do is we bring in artificial targets, artificial reference points. In this case, we're using a 140 millimeter set of spheres. Now, we've kind of condensed this down because these spheres can be up to 40 feet away from the scanner, and the scanner itself can be moved 50, 70, even up to 100 feet between the two positions if you're using the sphere targets correctly. So what we're going to do is we're going to first look at how we've got the sphere targets set up. Now you can see the three on the left and the three on the right. They are all of different heights. They are set up randomly. They're not in a grid pattern of any sort. They're not in line with each other. And this is necessary because the software is going to use the sphere targets as reference points. They have to be in unique random positions so that it can put this scan position together with the next scan position. We're going to leave 3 targets where they are when we move the scanner and move the other 3, as you can see in the video, forward in front of the scan position. We're simply going to move the scanner to its new position, grab the sphere targets furthest away, and then move them into their new position in front of the scanner in the direction that we're going to be moving. Now, as I said, these 3 targets here have not moved. So when the registration software goes to look at these 2 scans to put them together, they're going to look down from above. They're going to use pre-processing. It's an option in the software that's going to first identify these spheres as targets. Then it's going to look down at the 2 scan positions and see that there are 3 of these sphere targets that are common between these 2 scans. It's then going to use those 3 targets to lock the scans together. It's a simple principle. Again, make sure that these sphere targets are randomly displayed around the scanner. Move the scanner and leave 3 targets in the same position between the 2 scan positions. As we move to our left, we're going to again now jump the 3 new scan position or sphere positions here, move the scanner over them, and then these will now be the sphere targets that are furthest away. They will be the ones to then move to our left in front of the new scan position, leaving these 3 on the left here to stay in their position and be used as reference points for the next scan position. Hopefully, the different things that we've touched on today will help you when you're in the field. Our goal is to allow you to go and capture your data without running into some of the basic problems that we see a lot of people run into. We don't want an hour's worth of registration to become days worth of registration because of some simple mistakes made in the field. Anyway, this is Nick at Atlantic Laser Scanning. Remember, we do rent FARO laser scanners, and we do a ton of tutorials. If there's something specific you'd like us to touch on, please just email us at info@atlanticlaserscanning.com. In the meantime, good luck on your scanning.